Hi, this is Mrs. Nandor, and in this video we're going to be looking at non-ideal gas behavior. So far we've always talked about gases in an ideal situation. So within a range of pressures and temperatures. That's when our kinetic molecular theory points most accurately apply. However, there are situations when gases don't behave ideally, so we have non-ideal gas behavior. And the two main scenarios we look at with that are high pressure and low temperature. So if you dramatically increase the pressure or you dramatically decrease the temperature, you will start to see gases behave non-ideally. So let's look at each of those components individually. So one of our tenets of kinetic molecular theory says that gas particles occupy no volume. They're essentially just points in space. However, at very high pressures, the gases start to be compressed and they start to occupy volume. And so we can't make that assumption from kinetic molecular theory that our particles occupy no volume. So at high pressures, gases become compressed. And they start to occupy more volume than our kinetic molecular theory assumptions allow. Our kinetic molecular theory says they need to essentially the gas particles themselves need to occupy no volume. However, as you start to increase the pressures, you start to see that those gas particles are actually occupying volume, and so we have to take that into account when we go to calculate the pressure of a larger volume of gas. We can also see non-ideal behavior if we dramatically decrease the temperature. So if we decrease the temperature of a gas, the particles start moving much more slowly, and they start to form attractions between the particles. One of our tenets of kinetic molecular theory says that there are 0 attractions between gas particles. However, when we lower the temperature, they start moving slow enough that we start to see attractions between particles form. Since our usual ideal gas equation functions on the kinetic molecular theory assumptions, and kinetic molecular theory assumes that there are 0 attractions between particles, when we lower the temperature, our new equations have to take into account that the particles are going to be moving slowly enough so that there are some attractions being formed. So in these two scenarios, high pressure and low temperature, we're breaking some of those assumptions that kinetic molecular theory has us hold to in order to use the ideal gas law. This means that we need to use different equations to calculate pressure that involve these factors so that we can take these changes into account.